Hello everyone, welcome to Explorer Hub. So we are given the question, the zeros of a cubic function are -1, 2, and 3. Find the equation of a polynomial that has a y-intercept of 8. So we have learned from the lesson that a family of polynomial functions with zeros a1, a2, a3, and so on can be represented by a general equation of the form y is equals to k x minus a1 multiplied by x minus a2 x minus a3 and so on. So we will just use this as a reference to solve this. So now we know that the zeros we've been given in this question are -1, 2, and 3. So we can just substitute those into our general equation. X minus, this would be a plus 1 since minus is plus, x minus 2 and x minus 3. So this equation would satisfy this, but now we need this equation to also satisfy a y-intercept of 8. A y-intercept of 8 is when the y-axis, when the y point is at 8 and the x-axis is at 0. So basically, we know that the point is 0, 8. So we can just plug this point into our equation 0, 8, since if you look at a graph, the y-intercept is when the x-axis, when the point is 0 at the x-axis. This would be 0, 8. Now we can move on and we can just simply plug this back into this equation. These values, so y is 8. 8 is equals to k times x is 0 plus 1, 0 minus 2, 0 minus 3. Now that we have this, we can just further simplify. K1, k minus 2, k minus 3. This would give us 8 is equals to minus 2 times minus 3 is positive 6. Positive 6 times 1 is just 6. So that would be k times 6. So therefore k is equals to 6 over 8, which is equals to 3 by 4. Now that we have this, we can plug this over here to get our final equation, which is y is equals to 3 over 4 times x plus 1, x minus 2, x minus 3. And this is our final answer. So, thank you for joining us. I hope to see you in the next lesson.